A few years after the Chernobyl nuclear disaster, scientists planted this unassuming little plant on soil contaminated with radioactive cesium. It didn't harm the plant. Instead, it took up and stored the metal in its shoots. And it's not just radioactive cesium that it can suck up. It can also extract copper, zinc, even gold from the soil, all ready to be harvested like any other crop. Fast forward 30 years, planting flowers to actually mine metals is on the brink of becoming a business and an alternative to conventional mining in unconventional areas in many parts of the world. Like on this field of flowers in Albania. Its harvest? Nickel. But can this really take on huge industrial mines? Indian mustard and similar plants are called hyperaccumulators. They evolved to absorb metals from the ground and store them in their shoots, leaves or sap to scare off predators or pathogens. For the plants themselves, the metals are harmless. In the 1980s, biologists began to put those plants on soils that had been contaminated by mines or smelters.
The value is that you clean up the soil, and we call that phytoremediation.
Anthony van der End is one of the busiest researchers for that tech.
Now, if you do that with a metal that actually has value, you could then extract that metal from the biomass, and that's what we call phytomining. We know of about 700 hyperaccumulator species around the world.
Alpine pennycress takes up zinc. Macadamia trees absorb manganese. This fern sucks rare earth elements out of the ground like neodymium. Once dried, these critical metals form anywhere from below 0.1 to 2% of the plant's weight. Now, this is where it gets really interesting. Many hyperaccumulators absorb nickel, a metal which sits right in the topsoil in many parts of the world and is in really high demand. Some researchers and a handful of startups have taken notice.
The minimum sort of target we are looking for on the land today with the natural plants are around 1/3 of a ton of nickel per hectare.
Eric Metzner operates the phytomining startup Metal Plant. They now have their third harvest on a 10-hectare testing field in northern Albania. Here the soil is too full of nickel to grow food crops with good harvest. But then there's also too little nickel, only 0.2%, to just scrape the topsoil and extract it. This makes it an ideal place for planting this nickel hyperaccumulator. The plants suck up the metal and store it. Once harvested and dried, about 2% of their dry weight is nickel. Metal Plant grind and burn the plants, leaving an ashy concentrate or bio-ore. The ash gets washed and by using sulfuric acid turned into a liquid. It's then filtered and crystallized into nickel sulfate, fit for use in large batteries like those in electric cars. Metal Plants say they get over 3 tons of nickel per season. That's not bad, but for what the whole farm produces, it takes a conventional mine just about half an hour to extract that much nickel, although with a pretty different result to the landscape. Nickel mining in particular can be very environmentally destructive. We recently published an investigation about the devastating consequences of nickel mining in Indonesia. In short, conventional nickel mining usually requires deforestation of large areas. It produces large amounts of toxic waste that can contaminate rivers, soils, and poison people and the environment. And it's among the metals with the highest greenhouse gas emissions per ton. Phytomining is supposed to be different from that.
So environmental impact is relatively low, but you need to do this, of course, in an area that is not already rainforest.
It intends to avoid toxic tailings, and scientists say it could produce at least 90% less emissions than today's typical processes, because the amount of CO2 captured in the growing and released in the burning of the plants is around the same. And here's a critical benefit. Most of the companies and researchers are targeting areas that are barren, free of trees but not well suited for other crops, because the metals in the ground are toxic to them and the nutrients not sufficient. Hyperaccumulators, on the other hand, have naturally evolved to absorb metals. So in theory, phytomining doesn't compete with other ways to use land. It could even help them.
The areas will be cleaned up. It could be probably used for forestry or for recreational purposes, growing plants.
Rupali Datta is researching how phytomining can do just that. This is the exact opposite legacy of conventional mines like in Indonesia, where once rich nature is left behind destroyed. But just like the pros of farming, phytomining has its downsides. You get 1, maybe 2 harvests per year, which could be lost due to a pest, fire, or flood. And then, after some 20 years, the metal in the soil is used up. And to produce what one conventional nickel mine churns out in a year, you would easily need 200,000 hectares of land. That's 2.5 times the size of New York City. For the past 30 years, scientists have been trying to make phytomining work, without much movement behind it. That was until 2024, when the US Department of Energy gave those scientists and a few companies $10 million to make it a reality. Why the hurry all of a sudden?
It's really about guaranteeing supply, right? Concentration of any commodity in one country, it's always a high risk.
Kwesi Mpofu analyzes the global market for metals, including nickel. Today, more than half the world's nickel supply is produced in Indonesia, often controlled by Chinese companies, and that dominance is only projected to grow bigger. Meanwhile, the demand for nickel will grow as well, almost 70% by 2040, thanks to the need for more and more EV batteries. And all that new demand is making phytomining for nickel more attractive than ever before. A couple of years ago, Bloomberg NEF looked at the economics of phytomining. The estimated cost to produce 1 ton of nickel was so high that selling it at the average price of nickel would leave no room for profit. But since then, that average price of nickel has increased. Metal Plant wouldn't tell us their production costs, but say they aim to match the numbers of any other nickel on the market.
The goal right now is to get demonstrations of the price parity, and we call it like a green advantage or a green dividend, where you're like, okay, this is equally the same cost, but better.
What helps Metal Plant is that they combine the phytomining with carbon capture, for which they can sell carbon credits. Close to their site in Albania, they take these rocks, crush them and mix the dust into the soil. The dust captures carbon dioxide from the atmosphere and binds it to the ground. Plus, the rock dust tops up the nickel in the soil because it contains quite a bit of it as well. This sounds like it could be a business model. There's just one thing left to make it work, and that's scale.
The economies of scale really plays a key role. So the bigger it gets, obviously the cheaper it gets. But for phytomining, the biggest downside has actually not been the cost, it's been land.
Metal Plant currently operates on 10 hectares in Albania, but want to add a couple of zeros to that number.
30, 40, 50,000 hectares of land. Like our goal is a ton of nickel minimum per hectare.
1 ton of nickel per hectare is a highly ambitious target. Many researchers are looking at just a quarter of that in their best case scenarios. Let's say you would like to replace the current global conventional nickel production. You'd need up to 15 million hectares of fields under realistic scenarios. That's about the size of Tunisia. Looking at suitable land, the potential for phytomining nickel is quite high, especially in countries like Indonesia, the Philippines, Brazil, South Africa or the US. It's unclear how much those areas amount to. An estimate for the US is 4 million hectares, although some of that is conserved land. Depending on the location, plant performance can vary a lot. A plant that's easy to farm in one region can elsewhere be an invasive species. To develop plants that are highly productive in different parts of the world, scientists are currently trying to put together the most promising genes of hyperaccumulator plants. But phytomining with a monoculture at the scale of thousands or tens of thousands of hectares would likely harm the environment too.
Wherever you're doing intensive farming, whatever you're using, fertilizers, pesticides, water, all of these are also applicable for phytomining.
And then we'd have those thousands of tons of harvest too.
There's no factory in the world that can take that biomass at this point to turn it into a saleable product.
Up until now, phytomining is only happening in a few labs and on a few testing fields, supported by research funds. But when it's time for a reality check, it will be tough. So what can phytomining do?
It can definitely not replace conventional mining. It can be an additional process.
For most metals, science knows too little. Gold could be an interesting target if its price continues to rise. For nickel, phytomining is already promising, but the challenges to scale up production to an economic level are enormous.
If the industry is able to achieve these, I think that over the next decade or two, phytomining could start playing a key role in nickel production.
Big mining firms could use phytomining to get the last bits of nickel out of their almost depleted mines, while cleaning up the area for other uses. But
I can safely say there is no interest whatsoever from conventional nickel mining companies to invest anything in phytomining.
what he believes is a realistic application is not for mining companies. It's for communities in countries like the Balkans, Turkey or Malaysia who can't grow food crops that well on certain parts of their country. They could generate some income with nickel, securing a small domestic supply of the metal while cleaning up their soil. What do you think about the ideas of mining metals with plants? Let us know in the comments below, subscribe for more videos like this and check out dw.com for more stories.